So now I'm going to go to the actual presentation. Cool. All right, so I'm going to be talking about benchmarks. Okay, how do you actually, and also the role that benchmarks and broadly testing plays in productionizing agents and models. You know, in traditional software engineering, we've gotten familiar with things like test-driven development, you know, CI/CD pipelines, and without that, we really couldn't ship software, you know, in a production sense at scale with so many people contributing to a code base. And what I want to explore today is what does that look like with AI? And I want to just start with the spoiler, which is these benchmarks that you see online, and we'll name some of them in a second, but the benchmarks that you see online, they should be a kind of narrowing point and help you focus on what you should choose to investigate further, but they're not a substitute for what's relevant to your use case, and they should not solely be responsible for helping you make deployment decisions, right? And you know, as the title of this talk is about, you know, people lying and misleading with benchmarks, I wanted to talk about that right up front before we get into like practicalities. You know, how can companies actually lie, right? Because like we've all had this thought in our head of like, is this really that good? Like they're saying this is like a new model or whatever. Is it really that good? There's a lot of ways they can stretch the truth, if I may say. Sometimes they'll rate performance of a model just as an input and output call versus that model being wrapped up as an agent with harnesses and tools. Like if a model can use, is being used as an agent with a harness and it can do web searches, it's obviously going to perform differently than just the raw model, right? When we look at an agent, we actually want to look at, does it complete the goal? Is it using the right tools and trajectory? And does it perform that without bad side effects? And this brings in another set of criteria that you also would have to evaluate on if you wanted to be honest, versus just a pure model, right? Another issue with how companies use benchmarks to lie is with contamination, right? I'm sure some of you have heard of this already, but there's, you know, when Grok 4.5 came out, and it's actually a pretty good model, but when Grok 4.5 came out, there was a disclaimer at the bottom that almost no one read on their release pages, which said this had contamination with one of the popular coding benchmarks. Right, they were at least honest enough to admit it, but most of these companies don't even admit it when they're training on the solutions to some of these benchmarks. You know, companies can also play with the effort level. You know, they can tweak whether it's instant or medium or high when they're running these benchmarks internally before they publish their leaderboard. They can change the pass rate. So usually pass at 1 is like considered the really high standard of it has to pass on the first attempt. But if they give it more attempts, and if any one of those is right, that can raise their success rate. There's also judge bias. Like, how do you even test that what the model produced is correct or not, right? And sometimes you have to use a judge, right? And you're just prompting an LLM to judge the output. Well, the LLMs, when they're being used as judges, also have bias. They actually prefer the tokens generated from another instance of the same model. They prefer certain items as an option in a sequence. So they might prefer the second element in a sequence every time more, or at higher probability than the third element. So if you just swap the order of, you know, what's in the RAG context or what the options are that it could pick from, it might pick a different option. They also prefer longer verbose answers over short answers, which doesn't really speak about accuracy. These are some of the different ways that you can see that. And of course, there's also, you know, missing economic data. Maybe they paid a lot more money to squeeze out the little bit of performance by playing with some of the above things, even quantization, which is not on here, right? And so now I want to talk about some common, you know, benchmarks. Again, this is just a starting point for you. This is not for you to make, not to make a decision on your behalf. So in terms of algorithms, this is just input output, right? You want to give it a prompt and you want it to generate some code. It's not doing like repository navigation. It's not like using a terminal. It's not resolving issues in GitHub. It's not doing any of that. It's just like creating an algorithm. And so these are 4 different common benchmarks. There's definitely a lot more out there. And I kind of notated it with 1 or 2 virus icons. And why did I do that? Well, that's just roughly telling you how much more contaminated the ones on the right are than the ones on the left. The reason why is, and you'll notice they're all contaminated, right? So the ones on the left that have 1 is because only the inputs and outputs to the benchmarks are publicly available. For the ones on the right, the inputs and the outputs and the golden solution is publicly available, and the models can train on that. This actually comes down to, this actually brings us to the two types of contamination that we see, which is a model learning, memorizing the output for that input, or is it also memorizing the solution, right? So there's two different types of contamination. That's what I use to annotate these. I would argue that those two on the left are a little bit better than the two on the right because they're not as contaminated. However, all four of these are contaminated. I would expect someone to ask me, what does a problem look like? It looks like that. Don't bother squinting. This doesn't matter. It's just, someone's like, what is it? What is the problem, right? All right, moving on. This one is these are SWE benchmarks. So this is like actually doing, using a terminal, solving issues, maintaining a repository as you add new features and dealing with feature creep, right? So there's SWE Bench Pro, there's Deep SWE, there's SWE CI, continuous integration, right? So again, same concept. They're all contaminated, some more than others. And this is really expensive to run, right? And a lot of times people don't run benchmarks because they just rely on the leaderboard, and those benchmarks are run infrequently. And so, running GPT 5.5 on SWE Bench Pro, which is just one of these, right, like top left, just one of those, costs $3,000 to $10,000, right? $3,000 if you're just using the public tests, and up to $10,000 if you also pay for the private tests. It's a lot of money, and that's just one benchmark, right? So we also have, outside of just coding, there's a new one that just came out not even 2 months ago. It's called Agents Last Exam. So maybe some of you have heard of Humanities Last Exam. Humanities Last Exam had some issues of, I think, 30 or 40% of the answers were wrong. Okay, surprise. So there's a new one called Agents Last Exam, and this one actually has a twist in that they want to look at the tasks that actually impact GDP. So they're looking at, I said GDP, not GPT, so gross domestic product. So like engineering, architecture, media and arts, physical sciences, health and medicine. So they have all these different tasks. They have real humans producing golden solutions for this. So there's all sorts of benchmarks out there, and like I said, they're all really expensive to run. And when you are running a benchmark, you're mostly looking, you kind of want to look at three things. And the benchmark that we just talked about so far is really just the first one of those three things, right? So one is like, how good is the model that you're working with? Just a core model, GPT, whatever, Claude, whatever, DeepSeek, whatever, right? The second one is the application, which is, probably gonna be an agent plus some extra stuff like the rest of the software. How does that overall work in terms of achieving your goals? And production monitoring is something that's not talked about enough. But with the way, AI-based systems fail isn't exactly the same way, which we know. But one thing I want to zoom in on is that they oftentimes fail silently, right? It's like producing an output, the data structure, the data type, all that's correct, and it's very confident, but it's saying the wrong thing. And so having good production monitoring, needs to be reconsidered based on how we've done things so far. But let's get a little bit more specific. How do you actually choose an evaluation framework? So when I say evaluation framework versus benchmark, I'm talking about something else right now. I'm talking about the software that you use to build your evals that are specific for your business or your project, plus the continuous monitoring, right? So one thing you want to look at is metric coverage, right? So you've probably heard of hallucination detection, faithfulness of sources, which also incorporates like recall and precision and all that. That's really boring because we've already solved this. Like all the frameworks can do this. That's why the koala is bored. And we actually want to move into 2026. Like this isn't 2023 anymore. And we want to look at custom metrics that are useful for application. So we don't want to like diagnose medical conditions using an agent, for example. We need to explicitly incorporate that as a criterion in our evaluation setup. Right. The second thing we want to look at is the integration footprint. We don't want vendor lock-in. We want to make sure that all the software and frameworks and tools that we're using allow us to move around because the best model changes by the day, by the week. And so we don't want vendor lock-in with the model provider. We want to be able to move between providers like Anthropic, OpenAI, OpenRouter, whatever. We want to be able to have interoperability with different vector DBs and different, agent frameworks. When I say framework, I mean something like Google ADK or LangChain or something. A third thing we want to look at, is the evaluation mode, right? There's really three ways we can evaluate an agent. I talked about one earlier, which is LLM as a judge, and I mentioned that it has some biases. Above that, I would say there's reference-based, right? So you actually have an answer that is the correct answer, which means you need grounded labeled data. But the top one is the cheapest to evaluate. The middle one's a little bit more expensive because you're paying for more tokens, but you don't need a ground truth answer. You can have the LLM judge it. And the bottom one is the most expensive, but it's oftentimes the highest quality, which is when you have people, especially domain experts, reviewing it, right? Like the way they created agents last exam was a lot of human in the loop, right? The fourth thing you want to look at in your checklist as how you're picking out software is a developer experience. You know, if you have a Python shop and all your stuff's going to be in Python and you're already using PyTest, then deep eval is going to work better for you. If you're doing more DevOps stuff and you have a lot more YAML configuration, then maybe prompt foo is going to be the same thing. But they're both performing the same role. You want to respect your existing team workflow instead of just flipping the table. The fifth thing is going to be observability and tracing. Like I said earlier, LLM-based systems can fail silently. We don't want that to happen. We want to do production monitoring. So we also want to trace requests. Maybe we take 1/10 of every user request and we trace that. And we can analyze that with a more powerful model with human overview. But basically, this is the development lifecycle for a good, reliable, production-worthy agent. You find a good benchmark that's suitable for you. You create scenarios that are specific to your use case. You also create adversarial scenarios of how does the agent handle someone who's trying to prompt inject it or something else. And then you want to do, before you roll it out to production, you want to do a shadow deployment, right? So shadow deployment, unlike a canary deployment, in a shadow deployment, you are taking real inputs from users, so it obeys the same properties of real user traffic spikes, right? Real network activity, real questions. This isn't tests, like these are real inputs. But the outputs of your shadow deployment don't get used. They just get logged. They don't go to the customer, right? And then once you have built some confidence there, then you can do ongoing production monitoring. So I actually want to try a simulated example. Don't worry, there's no coding. We're just gonna talk out loud. But I just want to try a simple example, and I want to really stress the point that coming up with this eval stuff is actually way more work than building the agent, because you're not even building the agent, another agent's building it for you. But let's say we wanted to find real world scenario. Like we wanted to find a venue in Austin that could hold at least 100 people. We want the agent to tell us what the pricing differences are, what the availability dates are. We want it to actually recommend one of those three, and then we want it to draft an email, right? So I want to feel free to answer some of these questions. Just raise your hand or yell it out loud. But what counts as success, right? So again, 3 venues, 100 people. Does anyone want to raise your hand? Like the answers are on the screen. Like what counts as success? Occupancy, yeah. So if I need 100 people to fit, so if it's a 50-person venue, then it's not going to cut it, right? So capacity. We actually get 3 real venues, not fake made-up venues or venues that don't exist anymore. We want to get price information. We want to recommend one, and we want an actionable output, which is an email draft. Okay, well, what about what has to be correct? What's actually factual, versus subjective, right? The address, yes. I didn't actually mean to click that. I'm sorry. The address, the pricing structure, the availability. Maybe additional stuff like parking logistics. Like if it just makes up, like, hey, there was a giant parking lot, and there's only 3 street parking spots, people are gonna be pretty pissed. You're gonna lose a lot of interest in your event. That's why I give you guys those little parking vouchers. What actions is the agent allowed to take versus not allowed to take? Anyone wanna guess something it shouldn't do?
Send the email.
Send the email, yes. We don't want it to send the email, we want it to draft the email. Anything else that it should not do?
Book the event.
Book the event. We don't want it to be using money.
Call them on the phone.
Call them on the phone. Yeah, that'd be kind of creepy too. Sign a contract. We don't want it to sign a contract. Exactly. Yeah, you guys got it. You guys are building agents. Yeah. So these are things it can do, right? So it can search public sites. It can use venue APIs if we gave it that. It can draft the email, and then this is what you guys already said. Should partial credit be awarded? You know, some use cases partial credit is good, some use cases it's actually not, right? In this case, I would say yes. You know, maybe it found 3 venues, but it doesn't have the, you know, availability information. That's still partial credit, right? And this is like, yeah.
But like, partial credit is kind of weird, because like, if it found like 3 really, like, real venues,
Yeah.
but it sent the email,
Hmm.
you know, that's like really bad.
Hmm.
Whereas if it only found maybe 2 venues, or like one of them, you know, closed like last month or something like that, that's like better
Yeah.
than if it found you 3 but like actually did something destructive.
Absolutely. Yeah, that's a good point. So how do we score all these different attributes, all these different criterion, you know, cost, latency, unnecessary tool calls? You know, we want to give it full credit. Credit means like full points if it's within budget. Maybe the budget is 50 cents within 3 minutes, and it doesn't perform redundant searches, and it's not running on and on and on after it already has an answer. So how do we prevent the agent from gaming the evaluator, right? So something's going to test it. What if this starts cheating the thing that's testing it? What if we get a little runaway OpenAI action on Hugging Face? And what do we do for this? Anyone have any ideas?
How does the agent know that he's being evaluated?
How does it know it's being evaluated? Well, maybe it's not necessarily that it knows it's being tested, but that it knows what the criterion are every time, right? And it can violate that without it appearing to be a violation, is more so. Not just that it's being evaluated, but even when it's being run in production. Same concept here. How do we prevent it from gaming?
We want our testing framework to evaluate a sample space that's kind of eerie in the way we would actually see. So you want
Yeah,
to pick
yeah, that's part of it, yes.
Like a golden data set?
Yeah, that's part of it. Anything else? So we actually wanted to give us citations. Every time it makes a claim, hey, this is a venue, it exists at this address, it's like, well, give me a link, give me a Google Maps link or something. We want to make sure that the quoted price doesn't include additional fees, right? You go on some of these travel sites or whatever, and they, or you know, Ticketmaster, name calling right now, but they just add a bunch of, you know, digits to your ticket at the end, and so you want to make sure the total price is within budget, and it's not gaming to find the ones where prices are hidden, right? So these are all the 7 things we just talked about. You don't need to read that. But this would be like an example of a scorecard, right? So I did this in like Google ADK a while ago, and you can create criterion inside this criteria. But you can give it different weights, and if it meets a certain threshold overall, it's fine. And based on what Hassan said, maybe some things are just like flat out wrong. So it doesn't matter if it got 100% or close to it if it sent an email, for example. So multiply by 0. So this basically comes down to 2 things, which I hinted at earlier. You have during and after CI/CD. Okay, so it's a 1-2 combo. So some common pairings are during testing, you can use DBeval. It's like a free open source framework, and then for ongoing monitoring, you can use Brain Trust. This is good for Python, good for traceability. But I think this last one, it doesn't work well with the LangChain ecosystem. So if you are using LangChain, you can use Ragus for evals. You can use Langsmith Trace for ongoing visibility production monitoring. If you want something that's pure open source, because the last 2 had at least one that was not, you can use this. So DBeval is, I think, MIT, Arise is like either MIT or Apache. And for ongoing visibility, Arise has a paid managed version, so you don't have to set up your own infra, or you can run your own infra. So these are some like common pairings. I'll just like cycle through those really quickly. So that is one, that's another, that's another. And then, you know, this is, so far we're talking about like agents and all that. I wanted to also talk about the model side of this, right? Which is like, do the models actually match some of the hype that we're seeing? There's a lot of like weird marketing around models. In fact, in the last few weeks, we've had quite a few new releases. This isn't even all of them. We had Communicate 3, Opus 5, the 3 GPT 5.6 variants, Grok 4.5, DeepSeek V4. You know, there's also a Gwen one that just came out a couple days ago. There's so many that are coming out all the time. Amazing, easy to keep track of. So the problem with some of these model performance claims is, this is especially true when you're not running the model. model, which most of us are not, if you're relying on another party to run that model for you, they could be doing a lot of weird things. Okay, so they could do silent weight updates. They could change the actual weights of the model as a minor version update, but they don't announce that as necessarily in the model handle. The model handle stays the same. So I remember 2-3 years ago when you would use GPT, it would have like a date code at the end. It would be like 0913 or 04 or whatever, right? They don't really do that as much anymore. They just want to be in full control and give you a lot of opacity onto what they're actually doing. They could change the quantization level. Oftentimes these models are running at 4-bit, but I wouldn't be surprised if they're running at even lower quantization levels. They could change how they do speculative decoding, and in speculative decoding you actually have 2 models, and they're not really being transparent as to what the second model is. And they could change what that second model is in production all the time. They could throttle you, right? They could shunt your traffic to a weaker setup. They may be actually playing with the effort level. Like the medium effort level today isn't the same as a medium in a week from now. And obviously you have new releases, and that changes which model's actually worth using comparatively. So I saw this cool Reddit post. This is from July 29th, and he's like, "Hey, I don't like this Opus 5 thing. It's doing too much, doesn't follow instructions, makes a lot of mistakes. So we went back to 4.8. Right? Does anyone else have a similar experience? 4.8 is better than 5, and when 4.8 was out, people were like, "Oh, 4.6 is the best, right?" So I actually caught this 5 days before this Reddit post. Okay, so I actually found you don't know how long it took me to get him to post for that photo, but I actually the day Opus 5 came out, I tested it with my own custom benchmark, and it was horrible. It was 8th place, and you can see it right here. It's I did the top 10 of the day, and it was an 8th place. 4.8, the old Opus model, was a 4th place, right? So 72% solve rate versus 57% solve rate. Opus 5, based on this data, I know it's kind of a little hard to see, but I'll just read it to you. Opus 5 looks to be a cost optimization, not a performance enhancement, right? So it's significantly cheaper than 4.8, right? But it's significantly worse in terms of performance. It is faster, so it seems like this is actually a lighter model, is what I'm getting. So I actually tested, DeepSeek V4, which just came out. Right? Until recently, a lot of people forgot about DeepSeek. They're pretty hot, last year. They just came out in the last couple of days. They released DeepSeek V4 Flash, and I tested it this morning, and it was number 5 in my lineup out of 11. And there's a lot of other surprising stuff, and this stuff changes literally by the day. Today, GPT 5.5 is actually the best model. And what I'm testing it on is code and algorithm development, right? So GPT 5.5 is the best. Surprisingly, number 2 is Grok 4.5, right? Grok has been all over this board. Grok, when it came out, was also a number in the top 3, and it descended into the middle, and it's been kind of floating around. But it's tended to be pretty cheap and pretty fast. Some other surprising things, 5.5 is better than 5.6 Sol. DeepSeek V4 Flash isn't too far off from Claude Fable 5 today. And I really want to stress this point. This is only for today. This changes a lot. This changes really rapidly. Kimmy, oh my God, all the marketing hype. Yes? How rapidly? Well, I test it every day, and it tends to change every day. So I compute a tau coefficient, and today was really bad. It was 0.5. So anything close to 0 means everything's flipping around. Anything close to 1 means it's constant, right? And I usually see tau values between 0.5 to 0.8. So, yeah, so for example, Fable, so in July, right? In the first 2 weeks of July, I would tell you Fable is the best model, if you just care about performance, right? Then Sol, 5.6 Sol came out. And the last 2 weeks of July, not only was it a little bit better than Fable, it was 4 times cheaper. So if you're not reconsidering what models you're running, at least on a bi-monthly basis, I would say you're burning money and you're getting worse performance, and you're gonna have to go redo a lot of work. Like that guy did it who was angry on Reddit. He's the only guy angry on Reddit, by the way. But you asking something?
I was going to
if you remember, just raise your hand again. Yeah.
So here what you're basically pointing out is like even the same model, like from one
Yeah.
to the next, just that performance. And sometimes like we get that sense like I'm using it, it's like, oh, Fable was so amazing when it came out, and for me right now it's like, oh, this is garbage, like I can't even read the top of it. And it's like, but they promise, oh, it's the same exact model, like it didn't change.
It's the same name,
Yeah.
right? But it's not the same model. Yeah.
Sorry, Bombay. What's your sample size for this function?
Yeah, so I run 40 problems. I do 20 problems that are medium, and I do 20 problems that are hard. When I say medium and hard, I'm referring to ELO. So anything over 2,000 ELO score is considered hard. Anything between 1 and 2,000 considered medium. A model with an ELO score of that amount will solve that problem at a 50% rate. So that's how that gets measured. If you, I'll show you a link, and you can see the statistical like differences. Yes.
Do you change the tests every day? Or
Yes.
every set?
Yeah, so good question. So this is a personal project I started because I got annoyed with model variability. And I actually run, so the thing is, I talked about contamination earlier, and I like to eat my sushi fresh, so I don't want any contamination. So I actually generate new test cases every single morning. And you're probably asking how I do that, that's my IP, I'm not gonna tell you. But I generate synthetic coding test cases every single morning, and I run them against the models, and then I have a second set of test cases which don't change. And if there's so today was actually weird compared to most days, in that the second canary tests were showing different kind of performances than the main tests, and that indicates that today's test cases were actually harder than yesterday's. But yeah, these are all. There's no contamination possibility here. Yes.
Yeah, I don't know if you said it, but say Fable got devoted in your list.
Yeah.
Does that mean that they actually thought it was, or that other models became better?
I didn't understand the question. It means
say,
what?
Say Fable, if it goes down in your ranking.
Yeah.
Does that mean that Fable was? Does that mean that other models became better than Fable, or that Fable became worse?
So both can happen, right? So there's the relative measurement, which is ranking, and then there's the absolute measurement, which is the solve rate, which is the third column, right? So if you saw that Fable had the same solve rate, it was like 50% 2 days in a row, but the ranking changed, that's because the other models performed differently, but it performed the same, yes.
Two questions. One is, you said how you generate things directly, but like, do you an example problem?
No, I'm not gonna show that. They're all coding. So I want to be clear, these are not agentic. This is not agentic testing, this is model testing. There's no tool calls, there's no internet, nothing. It's just, here's a question and create an algorithm that solves that.
And how do you determine the ELO? I know you said it's like 50% of the time that ELO doesn't solve it, but like how do you know what
So the problem itself corresponds to the ELO rating.
Right, I guess how do you label a problem?
I can't answer that, I'm sorry. But it's from the problem level, yes. Okay. Any other questions? Okay. So I sent one of my friends, he's not an engineer, but he's a founder and he has some engineers. I was like, hey, you should check this out. He's like, why would I read this? I'm like, because it tells you what's the best model. He's like, my engineers, they just kind of like, pick one and go with it. I'm like, just send it to them. And he responded with this in the morning yesterday, and he's like, thank God for your article. We can see deliberate slowdowns, and we're gonna be something better. You should check this out. Like, this is me wearing the same shirt because it's this morning. And I have a lot, I have like 27 at this point. It's like about a month old. So I would really appreciate it. This is the first time I actually plugged anything in 10 years, or 6 years for me, but I would appreciate it if you don't mind subscribing. It's completely free, you don't need a Substack account, but it is a Substack. And it'll just tell you on the weekdays in the morning, like, what is the best model. These are blog posts. And what I'm gonna do sometime this week and next week is I'm actually gonna release an API. And that's gonna be paid, but this is gonna stay free. But I'm gonna release an API, and where I think this is headed is, I think there's this new concept of model routing, right? I don't mean like mixture of experts routing, I mean outside the model. So I think, if you look at Ramp, which is a fintech company, they released a model router. OpenRouter, which is a routing company, last week released a new endpoint where you don't need to specify the model handle. You just say, I want this done, and then it auto selects the model for you. And the goal is to maximize performance and lower cost. And my data, which is independent of what they're doing, does demonstrate that there's value here. And you know, if you look at, there's so many companies out there, like Uber's been public, but I have friends at various companies who probably don't want to be named, and they're like, hey, we're blowing through our yearly budget in this many months, you know, for tokens. And so I think where things are headed is, how do we optimize for this? And we can't rely on what the model companies tell us. Like they're hiding a lot of information. And so I want to build an API that basically is the oracle, so to speak, or the source of truth for the different routers that are being built. Some are being built internally, some are external. Yeah, thank you. All right, so logistics. Because there's only one talk today, you have a whole hour to mingle with each other. There's always really smart people in this room. Always impressed with who decides to show up here. So please talk to each other. You can stay here for an hour, after which you can keep talking in the lobby over there. Again, shameless plug. And I want to say, you know, if you want to give a talk, maybe a lot of times our talks are on paper, so if you've read a paper or you wrote a paper that you found really interesting, that's related to AI. It could be on more basic research, it could be applied research, whatever. Just come talk to me, say hi. All volunteer driven. And thanks again to Station Austin, which is the new name for Capital Factory for the event stuff at least. Yeah, thank you.
Questions in the back?
Oh. Yes.
Yeah, so when you have your ranking,
Yeah.
you think of it as like an engine has horsepower and fuel economy, right? Like a dragster has
Yes.
really bad fuel economy,
Yes.
but amazing horsepower.
Yes.
Right? So when we're looking at these rankings, right now, what I understood was it's ranking it compared to yesterday, right? But overall, how do we understand how the models are? Like if we went back a year
Mhm.
and we looked at fuel economy and horsepower,
Yes.
right? It might be that everything today is better than the best performance a year
Yeah,
ago. Like,
I would think so.
like actually above. How can you visually or somehow display kind of what the baseline was 90 days ago, 180 days ago,
Yeah.
a year ago, 2 years ago, to say, hey, this is like everything is much better than what it was, because the relative day to day may not. It's very specific to a very recent activity.
I totally agree. So I do have two metrics to answer your question, which I already captured. One is the cost per solved problem, right? So that's like for a given medium or hard problem or easy even, how much money does it cost? And don't ask me about inflation, please. It's crazy, but how many dollars does it cost? Or how many cents does it cost to solve a problem, right? That's the efficiency side. It's like miles per gallon. The other one is just the absolute power of that model, and that's the ELO score, which is also in the ranking. So the rankings are relative, but you know, hypothetically, you could take the ELO rankings and cost per solved problem over time, and then just re-rank that. So that's totally doable. And I think this project is only about a month or so, 5 weeks old, and as it continues running, we'll start seeing some of these patterns play out.
Can you do like maybe like once a month, maybe once every 2 months, or whenever, of hey, just use a free model or open weight model that's like completely free, versus a paid model. When should you choose when? When like time is a constraint or
Yeah.
money is a constraint?
Yeah. So that is the job of a router, is to make that decision for you. It's not easy, and it's not something I think I need to explore for what my scope is. I don't know yet because I haven't built the API yet, but what I think it's going to be is the router is going to say, for this task, I need this ELO ranking, and I need this many tokens per second. Right? ELO like for that use case.
Do you make like a guide just so that people would understand?
Sure. Yeah. Absolutely. You had something?
Yeah, I guess model evaluation is like very hard.
Yes.
So it seems that people who are spending a lot of money on inference, writing
For consumers who can't tell. Well, so when I talk to like more B2C people, they're just like, hey man, I don't subscribe to anything. I just use a free ChatGPT. Some of the people who do subscribe, it's usually for like a hobby project. So I have a friend who, he does his own like coding projects on the side outside of work. And he's like, well, I already pay for like Claude. I know this week, like this or that's not as good. I'm not gonna switch because I already have like a subscription. I think that's definitely a good thing to explore. I think the bigger theme is that we still do not see a lot of generative AI and end user workflows and end user applications. And I think part of that is reliability, which we've touched upon today, and part of it's cost. Like unit economics need to make sense. And so if companies that produce services and provide services and products have more efficient that they're using more efficient routing, means that they can drive down unit economics or make unit economics better by driving down like cost of operating goods, right? And so I think that's going to allow for greater proliferation of end use cases. A lot of times people don't know it's AI; they just see that it works. Yes.
Why don't you add, or have you thought about adding like a Ferrari ranking into the leaderboard where you give like 10 problems that are 25 to 3,000 ELO and just say if you can solve a single one that gets rated like uniquely higher to see like which of these models are really topping out on the hardest problems?
I do something similar. So if you go on any one of these blogs, there's a head-to-head comparison. So it's more like a McNemar test if you've seen those. So it actually shows you like, yeah, these two models have the same or similar performance characteristics, but this one is actually solving some questions that the other one's not, right? So like you could see like, oh, you know, they both solved 30 correctly, and then one of them solved 10 that the other one didn't, and vice versa, or 5 and 5, sorry. And then you can look at those problems and say, oh, this one seems to be a little bit more of a niche here, right? Yes, in the back.
I do a fair amount of generative AI, and the discrepancy between the open list models in generative AI images versus the third-party providers plus the traditional, Google API the gaps are much larger than they are.
I agree.
in
Yeah,
other models.
I definitely agree. There's been less.
There's no coverage.
Yeah, there's less energy and attention for video and text. I think I mean I can speculate why that is. There's a lot of reasons. Part of it is that they're diffusion models, and there's just been less energy in that because diffusion models are actually newer than transformers. That's part of the reason. The other part of it is it's not as like easy to edit it. Like if something generates text, I can use a text editor and edit it, and now it's what I want. If something generates a video or an image, it oftentimes recreates the whole thing when I ask for an edit, right? And so I think we just haven't figured out that part yet. So the people are doing like weird stuff, like teaching agents to use Photoshop instead of like generating images directly. Yes.
Actually, a follow-up to that is, do you consider like image input in any of your tests?
No.
For example,
No.
for example, some of the issues I run into a lot is, for example, like a lot of these models are not good in understanding visually, like whether it is like, oh, you're building an app or a website, or even, for example, I give them these tests of like, given a bunch of images from different angles, like a 3D model, and it gives me a very basic, simple, like not a cube, but like a little more complicated, like a 3D model, and it's like, okay, now reassemble it, like in like whatever 3D system. Like most of these models just completely fall flat, and they believe that they got the same thing, and they are just like their visual sense is just so wrong.
Yeah, I agree. I mean, there's so many like niches within coding. There's so many other use cases outside of coding that I could run evals for. So just to give you an idea, like I'm doing medium and hard problems, 40 a day. I'm doing 60 million tokens a week right now on just on algorithm challenges. So one of the things I'm going to look at is, okay, everyone knows coding is like one of the killer use cases for agents, right? That's why I picked that. But the next thing is like, well, what are the next low-hanging fruits? And so that's something I'm still exploring to add. Yes. Any other questions? Ramon?
Let me talk about money. I remember that there were some editions of your newsletter where you added how much it costs you to run all this, but then you removed
No, it's in every one. I just moved it from the top to the bottom.
Oh.
Yeah. You want me to put it at the top for you?
Oh, no, no.
I can.
I just found it interesting to see the actual number.
So I'm spending between 100 to 150 bucks a day. It's more than I spend on everything else combined. Yeah.
Do you think if, like, a company for like choosing well for software test, like software engineering,
Yeah.
is it enough to spend that much money to get good results? Granted, we have like all the other, the VIP, everything set up right and so on.
Yeah. I think so. I haven't done it yet, but I think there's two problems with being able to produce an easy answer to your question. One is when you're using when you're doing like agentic coding, you're not doing direct model calls. You're using a harness. When you're using a harness, you have this like confusion because you can pay for the model with API tokens or you can pay for the subscription. So there might actually be performance characteristic differences in how you're paying. Because if you're paying for every token, they may give you better compute, right? So one thing I'm gonna do is do the subscription. I tried doing subscription, but I blew through like the highest Claude subscription plan within like a couple of days. So I need to figure that out. But usually I would imagine that for software engineering, not just programming, like actual repo management, I would imagine it could be more expensive. And you also have to factor in like additional tool calls and other stuff that you're gonna be using. I just want to like think of some good kind of use cases that I can tackle first, because it's like, well, it's good at coding for what? Like, it's good at doing security scans. It's good at writing front end code and like understanding visual symmetry, like Hassan was mentioning. You know, so this could easily go from $1,000 a week to $20,000 a week, and I've only marginally increased my coverage of use cases, right? So I have to be very selective with how I pick it. Yeah.
Do you track cache hit, cache misses, and then do you find that varies across the same time frames that you find model performance?
So is the way these, I have to be careful how I say this, the way these tests are structured, there's very little requirement for input caching. So I do not have input caching enabled because I'd just be paying for storage. Yeah.
One thing I don't think many of us did. Did you have the thinking level or the reasoning level on Kubernetes?
Oh, yeah. Are you asking what I'm doing in my test, or are you asking about it in general?
I guess in your ranking, right?
Oh, so I run everything at medium. Yeah.
So last one, do you think they figure out if you're testing them, like, do the performance work?
So Meta definitely knows I've been testing them. I actually complained to them because when MuseSpark came out, I ran 40 tests and I got 2 or 3 back. The rest of them just didn't respond, and they had an infra issue, and they're really nice about it. They gave me a refund, super sweet of them, and then they fixed it, and then it was actually operating really fast afterwards. So they know I'm testing and they've seen this newsletter, but I don't know about any of the other companies.
You're testing, what I understand is you're testing the ability to write an algorithm to solve a problem.
Yes.
Or that's just one component of writing good code.
I agree,
And
yeah.
you have also elegance and the ability to understand which library you want to use and try to shape it into a way that fits with the library and system.
Absolutely, yes.
You had like integrate that somehow in your testing?
Well, that's what I was saying earlier. So in the future, I will add software engineering tests. You know, again, these would have to be contamination free, sorry, this is the wrong slide. So if you remember, I was talking about this. So this is algorithm. I'm not using any of these, but this is similar to what I'm doing right now. And what I'm going to do in the future is more similar to this. Right? So this is like using a terminal, solving issues, reviewing PRs, adding new features, debugging a repo, making sure that this, continuation of the repo is healthy, right? So that's a future thing. Like I said, it's going to be really expensive, and I want to figure out first what are these very narrow specific use cases that people care about. So I need to do more market research before I decide what to do, because it's a lot of custom IP to figure out how to do the synthetic testing. And if I do one for web design, that may not be reusable for cybersecurity, for example.
I'm guessing you could expand your concept to other domains than code and have
Yes.
companies will give you their data to benchmark your stuff to
Yeah.
learn what works.
Yeah, that's just I just have to do a lot of biz dev ahead of me. to figure out what to prioritize. Like I said, this is only like a few weeks old.
How long does it take?
To run, it depends on my concurrency level. At a concurrency of like 18, so 18 things in parallel, I think it's like 3 hours. It's pretty heavy. Any other questions? Yeah.
I work on like a project that evals can be really long and also extremely expensive if you actually run the full set. And even one run can be like hundreds or thousands of dollars. I was curious when you're thinking about this for agentic stuff, like, because we have you want to run evals, you make a significant change, like you might change the way the context goes in, or what tools you expose, or like all these other things. Maybe this is too far from what you're doing, but I was curious if you have any thoughts on like how you would approach using evals effectively in the product loop if it was expensive to run and you had so many variables in it. Like, how do you actually move and make sure you're improving stuff?
So when you're doing evals and continuous monitoring, you can choose what fraction of real traces you analyze, right? So you don't want to analyze every trace, so you could say I want 10% or I want 1% or I want 5%. You could do a kind of narrower deployment. So you deploy to a fewer subset of your user base, and again, you can pick a fraction of those traces to log. That's for continuous monitoring. For actual offline evals, which I think is what you started with, you need domain experts to be like, these are the things that absolutely cannot go wrong, right? And you start from there. Cool.
So are you using it to chat functions for everything? Or
Yeah. It's just regular completion with maximum timeout and effort level and all that. Yeah. Anything else? All right, cool. For real, you can now talk. All right.